Hello and welcome. This will be a starting point for our little journey through Java Reflection API. We will slowly start by covering basics of Java Reflection and build some interesting projects with it. And our ultimate goal at the end is to build the dependency injection framework like Spring. So next time, if someone asks you during the interview how the internal things in Spring work, you will be able to answer that. Reflection API can be used to inspect any class objects, to find what class it is, what fields it contains and what types, what methods it holds, what interface it implements, what annotations are present. After the inspection is done, we can use those handles to actually extract bits and pieces from the object, field values, invoke methods, create new instances of the object, without knowing any implementation details at runtime. Now that we had a glance about the Reflection API, let's put it into use and create a JSON mapper. During this series, we will try to follow the TDD approach. We will define our requirements as a failing test at the beginning. Then we will perform minimal actions to implement it and meet the requirement. Afterwards, we will refactor the code to clean up, to structure it, and then we will repeat the process. One of the magic that we always see, right, when working with frameworks, we define an endpoint that returns a JSON type, but we specify a Java object, and it magically somehow converts it with some libraries like JSON. But underneath, actually, it is using the Reflection API. It is taking your object, it is scanning it for fields and values and converting it into the JSON string. We will have one generic method that will accept any kind of Java object. It is like a wildcard that we can pass anything here. The simplest first requirement is that when we pass an object itself, it is empty, it doesn't have any fields. So our expectation is that if we provide an object that is not null, we should return curly brackets. I prefer to split the test in 3 sections. Given, where we define our inputs and our configuration for initial state of the test, followed by when section, where we actually execute the logic we are testing, and ending with then section, where we perform our verifications or asserts. And it makes test more readable and manageable. We know what each section is for, and we can read as a text, given my input is an object, when I call the mapper, then I expect to receive empty JSON object. So now let's run the test. So first step of TDD, that we want to have a failing test. So we have defined one single requirement before writing any line of code, and now we need to implement it. What will be the simple solution to fix the test is just to return the empty string. Now that we have applied the change, let's rerun the test, and we have made it green. Now we'll loop back and define the next requirement, and let's write a test for it. Again, now starting with the given section, let's define some structure that has actually some fields that we can try to map. Records would be a perfect fit here. For example, we can use person with name and a last name. Now we create an input for that, execute our logic, expect to receive a JSON string that has 2 key value pairs. One the name, John, last name, Doe. Now that we have defined our next requirement, let's make the test green and really implement the logic. So how do we really handle this case and how we can access the reflection part? Well, everything starts actually with a class. So we would like to know what kind of class is associated to this object. This can be done and found out by using object get class method. So the class itself has all the metadata we are looking for. So let's inspect what it proposes us. Class dot, we can verify if this class is a primitive type. We can get declared fields. Sounds like we are interested in that. We can get a simple name of the class. We can see the access flags, annotations, and everything that is associated with this class. We are interested to provide a JSON structure, so we need to find all defined fields. This can be done by using the class getDeclaredFields. Let's go over one by one and see what's inside those fields. Probably we are interested in name, and a field has a method that we can invoke to extract this field's name. I would be also interested in type. And let's see, indeed it has a type. So now we can output this information and inspect any object. Let's run our test and see the debug output. So we have successfully scanned the class and found out that there are 2 fields, one name with type string and the last name with type string. Okay, now we know all the keys that we need to provide in the output. The only thing that we don't know is the values. But reflection also allows not only to find the metadata, but also extract information from objects of that class. To get a value, we can ask field and call a get method which accepts an object. An object is the instance that we are trying to read the value from. That's why it's kind of called reflection. We take an object, extract a class, then we find the field and then use the field on top of the object so we can extract a field from it dynamically without knowing anything about it. So in our case, we want to provide the object itself that we are passing to the function. It is read signaling that something is happening here. It is basically saying that when there is an access control, access modifiers, and we are violating them, the illegal access exception will be thrown. It's like trying to access a private field that we should not be able to. To keep it simple, let's just add it to a method signature. We will have to correct that also in the tests. But now we are also ready to print out the value. And let's run the test to see the output. And surprise, we have caused our illegal access exception. If we read to the message itself, I think it's becoming really clear what's happening. So we are trying to access a member of a class person that has modifier private final. So when we are creating a record, it's immutable by default. It is assigning a private final to each of its members. And now we're trying to extract these private fields. Of course, it is an illegal access. So Java has this security in place that is preventing us from reading values, but we can override that setting. When we are working with reflection, we can say before reading the object that we want to set it accessible. Marking it accessible, it is like removing the access modifiers and allowing our code to read the value from it. Of course, the good practice would be to disable the field back so we do not expose anything more that we need. Now we can rerun the test and see that we have successfully read values. We have a name, John, last name, Doe. Now that we have everything we need, we can implement our JSON response. We can replace this loop with a stream of fields, arrays stream, and provide fields. Then for each field, we would like to map it to a JSON pair. So for example, set the field accessible, extract name, extract value. We actually don't need the type right now. We still need to handle the exception, and that we have here a throws illegal exception will not work because streams do not work well with checked exceptions. So we will have to have a try catch for now. We will put here try and catch and actually rethrow it as a runtime exception. What does it mean? We will just rethrow the exception outside the stream. Now that we have name and value, we can return this pair, formatted name and value. Then we want to collect it into a single string response. For example, we can use collectors joining that will concatenate all the strings together. Delete the default return and return the output of this string. By rerunning the test, we can see indeed that we have generated two pairs and they are concatenated together, but they are not surrounded by the squarely brackets and not are separated by the comma. Actually, the collectors joining has additional parameters that we can pass. One of them is delimiter that is used between the values, then the prefix and the suffix. And just like that, we can collect all of these values and concatenate them together. And we have successfully generated our first valid JSON string from a structure that we didn't know anything about. By using reflection, we have scanned it and extracted fields and values. Time to refactor and make our code cleaner. We know that we will not throw this exception, we can remove it. Then we would like to do something here. Let's define a function that will be responsible for getting field value using this field and given object. So let's import it from the reflection package. We want to set field accessible. Then we want to retrieve the value and return it back. But we know that we need to catch and handle the legal exception. Let's just rethrow it as a runtime exception. If there is some broader issue, we rather stop. And we can have finally block that will set accessible back to false. So now we have our little function for reading field value. We can get rid of this try catch structure at all. and replace this field get with get field value by providing field and object. And the set accessible is also no longer needed. Much better. For now, I think code is pretty clear. We could still separate some things, but I think for now it's okay. For the next requirement, we know that when working with JSON format, the numeric values and Boolean are not enclosed in quotes. Again, we will start with the given section. Let's define a structure that holds string and an integer and create an input from it. Then we define the when section, and then where we perform action and verification. And notice that now number is not enclosed by the quotes. So how we would implement this requirement? There is only one difference, right? That here we currently enclose any value in these quotes. So let's remove them here. And now we would need a function that actually would either add them or remove them based on the field type. So if it's an integer, it should not add them. If it's a string, it should keep them. Let's define a helper function for that. Private string as JSON value. And here we will provide a value object itself. Before we go further, let's make sure that our tests are still valid and still passing. Let's add the default case where we add quotes to any of the values. Now that we have that, we can wrap this extracted get field value by as JSON value, and we can rerun the tests. Ideally, we want to run all of the tests. Only the integer is failing one. So now we have extracted the method without breaking anything in our older functionality. Now we are ready to implement the new logic. Pretty much the only thing that we need to add is check if this is an integer, and if it's an integer, then we should return back a non-quoted value. Probably we have done that in past using an instance of operator, and that's the thing we can actually use here. If the value is of type integer, then we just return the string value of it. And now we have successfully implemented the next requirement. Our all tests are passing. So the last requirement that we will define today and implement is handling the primitive values. We know that in JSON, not only integers should not be enclosed by the quotes, but also decimal values or other representations of the integer, like long, byte, short. In the given section, we'll define a type with all the primitive types that we have in Java and create an instance filling out those fields. Then, following the same structure, we define the when section and the assertion, where we check if all of the fields' numeric values are not enclosed by the quotes, except the character that should still have it. And we can see that actually test is failing as expected, and only integer is being done correctly. So probably you can recall from the beginning of the lesson that we inspected the class and saw that it was a handy method that is saying is a primitive. So instead of value instance of integer, we could try value get class is primitive. Let's run. I think we have solved the problem. But sadly, no. We have even broke our integer. But how it can be? We know that integer is a primitive type. Why it didn't handle it like that? Let's add that a debug statement and see what class actually we receive. And you can see indeed those are all byte, shorts, integer, long, double as we have defined, but these are the boxed versions, object representation of the same primitive value. Sadly, if we are running this check, if it's a primitive type, it will no longer be a primitive type. Well, we can define our own primitive function that will accept any value and say true if it's primitive, false if it's not. And we will check for boxed versions as well. And actually we can implement it in the same way that we had it before. So we can check if the value is instance of integer or the value is instance of long, and etc, etc. For now, let's not do this. Let's check with two values. So then we replace this isPrimitive call with our own implementation and rerun the test and see if we have fixed it for integer and long. Long is no longer escaped and the integer as well. Now the only thing is to list our all values here. We can be a bit more smarter. We know that everything is an object in Java, boxed types included the boolean and character, and the numeric values actually have a common inheritance. It's a number abstraction class. Even more, there are big decimals and atomics also share that. So now that we know that there is some common ancestor, technically instead of listing all the numeric values, we could provide here an instance of number, and it will cover all of the cases. Except that we know that we still need to include Boolean, as it's not a part of that, but will not include a character. And now that it is done, let's rerun our tests, and we can see all of them are green. And that means we have successfully created our first JSON mapper implementation. At each step we did verify that previous logic is not violated, and we have slowly, iteratively come to the result. Of course, it's far from being perfect. We need still to handle null values, we need to still handle arrays and nested objects. That's the thing that we will do in the upcoming videos. So if you like what you see, please leave a like, subscribe, leave a comment. I would really appreciate the feedback and support from you. Thank you for being here, and till next time.